Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Step 4 of the troubleshooting methodology is creating and implementing a resolution plan, and it begins only after a theory has been confirmed as the actual cause of the problem. This step is where technicians transition from diagnosis to action. Rather than jumping into quick fixes, the goal here is to carefully plan and execute a solution that is appropriate, non-destructive, and as low risk as possible. Depending on the problem, the resolution may involve replacing hardware, adjusting system settings, reconfiguring software, or applying updates. Each fix must be tailored to the problem and carried out with caution and precision. Structuring a resolution plan starts with defining exactly what the fix is intended to achieve. Whether the objective is to restore network connectivity, eliminate application errors, or bring a non-booting system back online, the goal must be clearly outlined. Once the objective is established, the steps needed to reach that goal should be broken down in a logical order. Technicians must also anticipate potential complications and prepare alternate options. A good plan avoids assumptions and builds in room for validation, rollback, and documentation throughout the process. Before making any significant change, verifying that current backups exist is essential. If a solution fails or causes unexpected side effects, a backup is the only way to restore the system to its prior state. Backups may include full system images, user data copies, configuration snapshots, or even cloud-based backups. This is particularly important when performing operating system reinstalls, repairing storage drives, or applying firmware updates. Without a backup, technicians risk data loss and may be unable to recover from a failed resolution attempt. Proper scheduling of the resolution work is just as important as the plan itself. Downtime can disrupt users, departments, or business operations. Whenever possible, fixes should be scheduled during maintenance windows or outside normal operating hours. If rebooting is necessary or system access will be interrupted, users should be notified in advance. Even when the work is minor, setting expectations about when it will occur and how long it will take helps avoid confusion and builds trust. Some resolution actions require authorization from management, the client, or a designated change control body. This is especially true in environments governed by compliance requirements, security policies, or data privacy rules. Even if the technician is confident in the fix, they may not have permission to proceed without formal approval. Change control procedures often include submitting a request, obtaining sign-off, and documenting who approved the action. These protocols protect both the organization and the technician from unintended consequences. Examples of resolution actions can vary widely depending on the problem type. Hardware-related fixes might include replacing a failing power supply unit, reseating memory modules, or reconnecting a loose cable. Software solutions could involve uninstalling a corrupt driver, rolling back a recent update, or reinstalling an affected application. For network issues, the technician might assign a static IP address, update a DNS setting, or reset a misconfigured router. Each of these actions must be deliberate, documented, and aligned with the confirmed root cause. Before implementing the fix, the technician should gather all tools, utilities, and resources needed to carry out the plan. This may include replacement parts, installation media, patch files, bootable recovery environments, or network credentials. Preparing these items ahead of time ensures a smooth process and prevents delays once work begins. It is also wise to prepare documentation or checklists that outline each step and include validation tasks to confirm whether the fix has succeeded. Rollback planning is a key part of any responsible resolution strategy. Even with a confirmed cause and a well-planned solution, fixes do not always work as intended. In some cases, a change can make the problem worse or introduce a new issue. To manage this risk, technicians should establish a clear path for reversing the change. This could mean creating a system restore point, exporting configuration settings, or cloning the affected device's hard drive. The ability to undo a failed resolution minimizes user impact and speeds up recovery. In complex resolution scenarios, multiple technicians or departments may need to be involved. Coordinating roles and responsibilities in advance ensures that each person understands what is expected of them and when their input is required. For example, a technician may need to collaborate with a network engineer to reconfigure switch settings or with a security analyst to adjust firewall rules. Communication and coordination are key to maintaining momentum and avoiding redundant effort or missed steps during implementation. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When implementing a resolution, there are situations where isolating the system is necessary to prevent broader damage or interference. If the issue involves malware, corrupted data, or unstable components, it is often safest to disconnect the system from the network and unplug unnecessary peripherals. Isolation helps protect other devices from infection or cascading failures. In some cases, booting into safe mode can provide a more stable environment for applying the fix, especially when troubleshooting software that fails under normal conditions or when driver conflicts are involved. Maintaining clear and ongoing communication with the user is vital throughout the resolution process. Users should be informed of when the work will take place, how long their system may be unavailable, and what steps are being taken to resolve the issue. If users will be unable to access their device or data during the process, that information should be conveyed in advance. Providing a point of contact for updates or questions also helps reduce anxiety and builds trust. Users are more patient and cooperative when they understand what to expect. Incremental implementation is a best practice that helps technicians avoid cascading problems. By making one change at a time and testing the result, technicians can clearly identify what effect each step has. If a change introduces a new error, it is immediately clear what caused it. Documenting each action ensures that any step can be undone or revisited if the outcome is unexpected. This is especially important when working with sensitive configurations, registry settings, or complex networking changes. Successful implementation is confirmed when the original symptom no longer occurs and the system performs as expected. The system should boot, respond, and operate within normal parameters without triggering new warnings or errors. If the system had multiple symptoms, all should be tested to ensure they have been resolved. Confirming that performance and functionality meet user needs is the clearest sign that the fix was successful and that the root cause has been effectively addressed. Some resolution steps require updating configuration files, system settings, or applying patches. If part of the fix involved correcting a misconfigured setting or outdated software, those changes should be saved and verified. In some cases, operating system or firmware updates may be part of the corrective action. Once the update is applied, settings such as BIOS configurations, network profiles, or user permissions may need to be reviewed to ensure they still align with policy and operational requirements. Post-resolution cleanup tasks help return the system to a normal, user-ready state. Temporary administrator accounts used during testing should be removed. Leftover log files, test folders, and installer packages should be deleted to keep the system clean. Any ports or services opened for diagnostic purposes should be secured or disabled. Reconnecting disconnected peripherals or re-enabling antivirus and security tools that were temporarily turned off is also part of this process. Leaving a system in a clean, secure, and stable condition demonstrates professionalism and responsibility. User confirmation is a key part of resolution verification. The technician should ask the user to test the system using their normal workflow, applications, and peripherals. If the user experiences no further issues and the system performs as expected, the resolution can be confirmed from both the technical and end-user perspective. Running a few basic diagnostics, such as a disk check or memory test, can provide extra assurance that the system is fully functional and no secondary issues remain. Not all problems are solved with a permanent fix on the first attempt. In edge cases, a workaround may be implemented as a temporary solution. These are often used when a hardware replacement is delayed, a patch is not yet available, or third-party support is needed. Workarounds must be documented clearly, including any limitations or instructions for the user. Technicians should follow up to ensure that the temporary measure is replaced with a permanent fix when possible. Before concluding the implementation phase, final checks should be performed to ensure no critical steps were overlooked. Logs should be reviewed and updated, system settings should be saved, and all peripherals should be tested for functionality. Confirm that the system is responsive, secure, and fully operational. Review any pre-established checklists to validate that all aspects of the fix were implemented and verified. Only once these checks are complete should the technician proceed to the next troubleshooting step, system verification and documentation. To summarize, creating and implementing a resolution plan is about more than just applying a fix. It requires careful planning, proper communication, and systematic execution. Technicians must verify backups, isolate systems when needed, and document every action. Implementing changes incrementally and involving other teams when appropriate ensures smooth resolution. This step sets the stage for confirming system functionality and documenting the outcome, making it a crucial turning point in the overall troubleshooting methodology. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.